Welcome to our deep dive into the world of Python data structures. Today, we're unraveling the complexities of how data can be organized and stored to enhance access and modification efficiency. Data structures are the backbone of programming, and Python offers a wide array to suit various needs. Let's break them down into two main categories: linear and nonlinear data structures, each with its unique characteristics and applications. In the digital universe, the way we arrange our data can make or break the efficiency of our applications. Welcome to the fascinating world of data structures in Python. Let's start with linear data structures. Imagine them as a line of dance partners, each linked hand in hand. In this linear arrangement, every element is connected to its predecessor and successor, allowing for a seamless single-pass traversal. First up, arrays. They're like apartment buildings for data, with each value living in a fixed address. Whether it's a static lineup or a dynamic, expandable list, arrays offer lightning-fast access to any occupant via its index. Next, we have linked lists. Picture a treasure hunt where each clue leads to the next. Linked lists excel in flexibility, allowing for easy additions and removals without disrupting the entire structure. Then there's the stack, operating on a last-in, first-out basis. It's like a stack of plates. You always deal with the topmost item, making it perfect for undo functions and syntax parsing. And let's not forget queues, where the first in line is always the first to be served. From printing documents to managing tasks, queues keep things orderly and fair. Now, let's venture into the realm of nonlinear data structures, where things get a bit more intricate, with elements branching out in multiple directions, forming a vast network of relationships. Trees stand tall in this landscape, organizing data in a hierarchical fashion, from the singular root to the sprawling leaves. Whether it's for database management or file systems, trees offer a natural, efficient structure for storage and retrieval. Graphs take the complexity up a notch, embodying the ultimate in connectivity. Representing networks from social circles to global mapping, graphs are the go-to for analyzing interconnected systems. And then we have heaps, specialized trees that prioritize the highest or lowest element at the root, making them ideal for priority queues and efficient sorting. Python, with its rich libraries and built-in data types, stands ready to implement these structures. From the simplicity of lists and dictionaries to the power of external libraries for complex trees and graphs, Python equips developers with the tools they need to structure their data effectively. Choosing between linear and nonlinear data structures depends on your data's nature and the tasks at hand. Whether it's the straightforward efficiency of linear structures or the complex relationships of nonlinear ones, Python's versatility ensures your data is always well organized. Dive into Python's world of data structures and unlock the potential of your data. Happy coding!